form the nucleus, which is a...
Okay, I'm gonna give you 4 words. Make a sentence out of gain, release, excited state, and ground state. Write a sentence. Gain, release, excited state, ground state. Ready, go?
I know how to write it.
Energy levels from ground state to an excited state.
Very good. That's a very good sentence.
But you didn't use. What did you say?
When they fall back down,
Fall to the ground state, they release
energy in the form of
light.
yeah.
Dude, I just used 3 words.
You say ground state, release, and excited state.
Yeah.
Then go back
That's the one I
to
did.
ground state
Okay, now make a sentence.
by releasing energy. What's that?
Yeah, I was just gonna do that one. Okay, Zeph, proton, and Coulombic attraction.
Okay.
So that one you might have to look up if you don't know. Zeph, proton, and Coulombic attraction.
Zeph is like the protons. Like,
So the more protons in the nucleus means higher Zeph means stronger Coulombic attraction. Is that what you said? More protons in the nucleus means a higher Zeph, which means a stronger Coulombic attraction. Okay. Ooh, okay. One more.
Radius.
S -1, lowercase c, and wavelength. S-1, look it up, lowercase c, and wavelength. That you're going to have to turn the page in your notes. Good job.
wait. I heard C and wavelength.
And wait, and that's -1.
S-1, c, and wavelength.
C is a constant.
C is a constant. What is it?
3.0 times 10 to the 8
8th. Good. Speed of light.
meters per second.
S-1 is a unit. What's a unit for?
Zap.
Nope.
It's yeah.
Per frequency.
Frequency. Okay, so what's your sentence? S-1, lowercase c, wavelength.
To find wavelength,
That's -1.
you do
The
C
unit for frequency.
over wavelength
Yeah, that's
to get your D looking thing in seconds.
Speed of light divided by, so c, divided by wavelength equals s to the -1, which is the unit for frequency. Let's go over the tests. So can you get that out next, please? Okay.
the E cell is the same.
ESL is the same. In the basket is a review for your final CUME test. Your final CUME test is going to be on Thursday.
Yay.
If you look at it, can you just look at the front cover? If you look at it, you'll notice that it's kind of a hodgepodge of things. Things I think that we either forgot or I recognize that we're not very good at and need to practice.
Stoichiometry?
No.
Solution map?
I know, I should just do one straight on that. But kinetics, I don't want you to forget. Not that you were bad at, you were very good at, but I'm like, oh, I bet they're just gonna forget. Monkey, narwhal, how to do reaction mechanisms, slow steps, solve for K with the units, from that's where you have to find the units. I noticed on our redox lab that dilution equation, M1 V1 equals M2 V2 was gone. So that's on there. Titration math is on there because that was gone. Understandably, we did that like week 1. So I'm bringing that back. There is a buffer pump, but it's not buffer math, you guys. Buffer math is easy. This is buffer molecules. So knowing that it makes water babies is kind of obvious. But what is the other molecule? So
H2O.
that's a water baby. No, you have to like look at the thing. So I wrote the test, took the test, and then wrote the review. The review is not exact. I cannot find exact matches. That's just not how they write exam questions. But it's very good. It's very close. I'm not guaranteeing that you have any time in class to work on it. The next available work day would be Tuesday. So if you don't have a Form B, you're going to have time on Tuesday. So, but maybe something you want to get started on this weekend. We're going to learn. So,
Oh my God. You really think I...
oh, and that ribbon. Thanks. When's the lab due? Monday. Do we do it on Monday?
Anyone want to? Yeah, we did.
Yeah, I'm using red today. Red today.
Give me a color, Wilson.
Will you give me one too?
No.
Ah,
Catch it.
What is that? Okay.
gotcha.
Dude, okay, I threw that one right to you.
All right. Before we start, I need you to read these 4 boxes. Somebody, you have to have like a super good understanding of these 4 boxes. Just one more time, read them to somebody, and then we're gonna start learning. Ready? Go. Okay. So then somebody decided that it's important that you know the location of every single electron and every single atom. Which is weird because we don't actually know the location of any of it because they are things. But thankfully, it's very easy. It just makes a pattern on the periodic. Stop talking. Makes a pattern on the periodic table. You do need to memorize this if you don't know it. Remember the S orbital starts at 1, the P orbital starts at 2, the D orbital starts at 3, and the F orbital starts at 4. So the tricky part comes in like right about here, right? It's okay because we can count to 100. So we have to pay attention. Like for our sample, we were doing osmium. Osmium is number 76. So we take the noble gas before it is xenon. After 54 is number 55. 55 is 6. S orbital. And there are 2 of them before I switch categories. I know I'm switching categories because the next number is 57. Now we're in 5D1 because 72 doesn't come next. 58 comes next. So I'm switching categories again. 4F14, back up to 72, 5D2, 5D3, 5D4, 5D5, 5D6. Okay? And then we can go ahead and be redundant to have both the 5Ds. If I'm doing something down here, stop. If I'm doing something down here, I need to make sure I include that number 57. I can't just skip it. Stop. Because it's a different category, okay? We are going to start here on these off-bow diagrams. Please write the electron configuration for oxygen to start. Oxygen. Oxygen, noble gas report is helium. After number 2 is number 3. Number 3 is in the 2s category, 2s2. Then I'm switching categories. Now I'm in the 2p category, 2p1, 2p2, 2p3, and 2p4. Even more ridiculous maybe than electron configurations are off-bow diagrams. So now what we need to do is instead of just writing what the formula, the numbers and letters are, stop. What we're going to be doing is we're going to actually be drawing arrows to indicate that there is a specific way you have to draw the arrow, and you cannot do it any other way. No, you may not cross stuff out. No, you may not draw a full arrow. That's not how it works. So your first arrow is going to be an up arrow pointed to the left, and it's going to be a half arrow. The half arrow indicates the quantum number half spin. Quantum numbers are something you don't need to know for the AP exam. You will if you ever take any chem class, but it indicates that when electrons are in an orbital together, they're going to spin in opposite directions because they are repelling each other, but they're squished together, so they're just going to spin, okay? To do an off-bow diagram, I'm going to go ahead and skip what's in the brackets for now, and it says in the 2s orbital, I have 2 electrons. So I'm going to go to the 2s box, and I'm going to draw 2 electrons. My first one must be my up half arrow, and my second one must be my down half arrow. Then it says I have 4 electrons in the 2p, but watch me, watch me, watch me, watch me. If I have 4 electrons, they have to be separate first, and then you go back and fill in. Electrons are all negative, so they're going to repel each other. They would not all squish, they'd spread out. This bracket means the electron configuration of helium. The electron configuration of helium is 1s2. So I'm going to go ahead and fill that in. Really, that just means fill in all of your arrows below it. Okay? Oh, I'm with you. Can you please, with your bad buddy, go ahead and write and draw the aqua for magnesium. Ready, go. Stop. Don't do what I'm doing. Don't do what I'm doing. Don't do what I'm doing. Do your own thing. Do it right. Check with your battle buddy. Make sure they got it right. Don't do what I'm doing.
You did it wrong. Wait.
I finished
Why is
right
it-
before.
Don't do what I'm doing. Do your own thing. I'm going to teach you something in a second. So really, what is it? Magnesium, neon, 3s2, right? Right here. Okay, good. Draw your stuff. Okay, so now, this is like baby chem, right? Honors chem maybe, but babies do this too. Writing electron configurations, transferring to very low level thinking. In AP Chem, what we need to recognize is that electrons gain energy and they move from their ground state to their excited state, okay? So this red part, go ahead and write it in red. Can you write it in red right over the top? Write in the excited state electron configuration, then draw in like red arrows over the top of your other arrows. Come get a red pen if you need to. Or
Wait. Why isn't
Get a
it
red
just? Why isn't it just at 3s?
Because we're talking about the excited state.
what would you like it to be?
MgMe3s2. I would think that it's just arrow up and down at 3.
Yeah. Okay, don't do what I'm doing. This is the excited state. That's what we're doing now.
So would I be right that at 3s?
Yeah, that's what I said. Now do it in red. Do the excited state over the top.
Trigger. So listen.
Trigger, you're right.
You are right, but I am too.
We're just talking about the excited state. Is that the excited state?
Yeah.
You're right.
No, what she's about to.
At the excited state, it goes up.
Okay, so the excited state is going to look like the pattern isn't right. That's how you know it's an excited state. I randomly picked this 3s2 down arrow and made it a 3p1. This could be 5p1, and it's not here, it's here. It really doesn't matter. There is no way for me to predict it. Okay? The point is, an excited state means that something is out of pattern, something jumped up. Now, how do I know this is still magnesium, though? That's the thing. So it's neon plus 2 more electrons. It's neon plus 1 more in the 3s and 1 more in the 5p. Neon plus 2 more still is magnesium. Okay, so things you have to recognize. What element it is, and that also that it is an excited state because it's not going to pattern. So when the music starts, can you please tell somebody why is that still magnesium and why is it an excited state? Ready? Go.
So there's 2 electrons still and some.
D2. Okay. A valence electron is an electron in the highest energy level. This goes back to being able to count. Counting to 100. Okay. The energy level is N. That was like a vocab thing that we learned. Lowercase n is energy level. This is the energy level, that number in front. 4 is bigger than 3. So the highest energy level we have is 4. It's not what's next in the pattern. It is not what's next in the pattern. It's just the highest energy level. In my highest energy level, I have 2 electrons. So that means titanium has 2 valence electrons in energy level 4. Core electrons are all other electrons. So how do I figure that out? Titanium is number 22. It has 22 electrons as long as it doesn't have charge. So if there's 22 and 2 of them are valence, that means 20 are core. Unpaired means it does not have a down arrow partner. Now this is how they test off vows without having you draw arrows. They can just ask how many unpaired electrons would it have. So if you flip it back, let's look at oxygen. Oxygen has 1, 2 unpaired electrons. Pair means 2, unpaired means it only has 1. Okay? When the music starts, please go through all 3 of those definitions. So let me make sure they understand what highest means. Ready, go. It would never be as easy as here's titanium, right? They're going to be ions. And ions, even though we're getting more used to them, sometimes scare us. All it means is it lost or gained electrons. So let's write the electron configuration for lithium. I'm going to write the whole thing on purpose. 1s2, and then I'm in the 2s, and I only have 1. A +1 charge means it lost 1 electrons, because now there is more protons. The electrons are lost from the highest energy level. So my highest energy level is 2, and I lost 1 electron. There only was 1 there, but I lost it. So the electron configuration for lithium 1+ is just 1s2. I don't need to write 2s0. Okay, highest energy level, not the next in the pattern, the highest. Okay, does everybody do Fe2+? See if we can do Fe2+. Ready, go.
It's right in the middle.
Is it going to lose it from the D?
No.
No, that's not the highest.
3 is low as why would you do that? 4 is bigger than 3.
4 is bigger than 3.
It's impossible.
I know you wouldn't. So just, I mean, like obviously over exaggerating, but just make sure you're not just doing the next one in the pattern. It's going to go from the highest because that's furthest out.
It crosses it all the way out.
Okay.
That's crazy.
Anions are way easier. Anions gain electrons and they just go next in pattern. So fluorine is helium. Then I got 2s2, 2p, 1, 2, 3, 4, 5. A negative charge means I gain 1 electron. Super easy, just next in pattern, this becomes a 6. Okay, those are way easier. You don't have to think you're just going to do that.
Wait, so just the next one.
It's just the next one over, or the next 2 over, or whatever the charge is.
I bet.
Okay, you need to go back to your front page, read all 4 boxes again, and get out the white worksheet packet I gave you the other day. Read all 4 boxes, get out the white worksheet packet.
Electrons are negative and attracts a positive proton.
Can you find this page, please? So I think it's the 2nd page, or the 3rd page, I mean. Where is your worksheet packet? I asked you. Please make sure everyone has their worksheet.
Found it!
Good job. Now help Will.
Come on, Will. Come on.
Carson, you have yours?
If I shoot it, it goes in. My pen falls just like
You're gonna run into the glass.
No, what is the rule about throwing stuff?
I didn't throw it, I gently tossed it.
Oh, you're not. The road is like.
Cole, can you help Will, please?
Yeah, help me.
Is it my tire? Is it my tie cooler than cool as this?
No.
I think both of you. I think
Actually, yeah, Carson is
I like your flower.
I think, yeah.
Yeah, I would pick the flower.
I think I would pick that.
Cole kind of like.
I don't like my
I think you look really. No, I love your blue.
Yes, I can.
I think all of you guys look
You
good.
don't like my shirt, Miss Collins?
I just got done
Is it
saying I
this
think
one?
all of you guys look really good.
Wait, why do you not like the full shirt?
No, I just really like floral.
You just said
Exactly.
Why
Like
are you
flowers are
fully
nice.
full?
No, your shirt is
Because he tried to
Bro,
throw
my shirt
back.
is so cool.
I didn't try.
So nice to have
All right.
a-
These are going to be the questions. I'm going to do the first one with you. I'm going to do the first one with you to show you what the words are. Okay. It says, explain why the atomic radius of oxygen is smaller than carbon. So brain eyeballs, right? We can think of energy levels as being layers. So if it has more energy levels, it's going to have a bigger radius. If it has less energy levels, it's going to have a smaller radius. So oxygen and carbon are both in energy level 2 because they're both 2p. So I'm going to say oxygen n equals 2, carbon n equals 2. That's where I'm going to start my thinking. I do have a tie for energy level, so I'm going to break that tie with Z. Z is how many protons are in the nucleus. Carbon is 6, oxygen is 8. So oxygen has a higher Z, which means it has a stronger, Coulombic attraction. Coulombic attraction is how strong that magnet is. So because that magnet is stronger, everything just gets pulled in a bit more. So look at energy level first and then look at Coulombic attraction. What I would like you to do is do 2 through 5 with your battle. See if you can figure out the words. Ready? Go.
So like I'm taking this, you're not gonna have to like explain what.
That's all I have to do.
Can we talk about number 4, please? Charges are tricky. But if calcium lost 2 electrons, it would lose an entire energy level. It went from 4 down to 3.
Crazy.
So if it lost a whole energy
That's
level,
great.
it's automatically smaller. Okay, yeah.
If it was just -1, did you say that CA by itself has more Coulombic attraction because it has an electron? There's that.
You can't use Coulombic attraction and electrons together. You could only use that and Coulombic attraction.
Okay.
That would be why you wouldn't have to write.
So
No, but just
so how do you
remember that is only for protons.
Wait, so what's CA and CA?
Yeah, I'm sure it's
Wait,
still
wait, if it was CA 1 plus a CA, that means that would be the same.
You're not going to have to break that tie, but whatever you think about it, electrons are not Coulombic attraction.
Yeah, so it would be the same.
Well, I'm sure they're not the same.
Why does extra electrons?
Good. So if fluorine gained an electron, look at me. If fluorine gained an electron, it's still going to be the second energy level. So we're not doing anything there. But what we did is I shoved another blue electron on there. It just creates a little repulsion, so it poofs out a little bit. All things else the same. Protons are the same, so Z is the same. Energy levels are the same. So now I'm like breaking 2 ties.
Is it that the same thing? 5 and 4? If it was CA 1 plus, then
No, because these are losing their state.
yeah, so if one's losing, then it's just going to get a little smaller.
Sure. CA doesn't make a 1 plus.
Yeah.
The reason why they lose 2 is because these are the valence.
Yeah.
There's a reason why these lose 1 is because those are the valence.
Yep.
They're very easy. Okay. I'm giving you some homework. On the front page.
I know that's a legal.
No.
Miss Collins, I'm not even gonna do it. I don't hate it. I really wish I could.
You're a
I'm
liar.
so
You don't
busy.
wish you could. You wouldn't do it.
Okay.
Miss Collins, I wish I could, but I don't have time.
At least have like the respect not to lie to me.
I wouldn't do it.
On number, the worksheet 1 is on memorizing the order of EMR in those 2 math equations. It's 1 through 17, but don't do 16. So 1 through 17, not 16. It's multiple choice, but that's just if you need practice on memorizing order of EMR in those math.
What's the
Right.
What's the first quiz?
So,
it's the order of like.
atomic structure and atomic structure and periodicity 3 is if you're struggling on the electron configurations and off-bow. If you need extra practice on that, that's for you. If anything, you need to do 1 through 11. These are all situations of breaking ties, thinking about energy levels. 1 through 11 on this third one. If you're going to do anything, please do that.
Why is it
Right, so
microwave?
should I-